Hello, my name is Abigail Sykes, and I'm a PhD student in the Machado Lab at North Carolina State University. My research currently involves investigating the impact of on-farm biosecurity on the spread of infectious swine diseases. In this video, I'm going to guide you through the interpretation of the results from our recently released biosecurity app. If you would like to find out more about the methodology behind these results, please visit our overview of the methodology video. In the app, we have aggregated these predicted risk results into different outcome levels for each production system. Here on our y-axis, we have the predicted outbreak risk calculated by our model, and across the x-axis, we have each system. This allows for users such as yourself to understand your performance compared to your peers. This will be anonymous, meaning you will only be able to see the name or any identifying features of your company, but others will be blinded. We also offer a more detailed exploration of the predicted risk data, showing the distribution of individual farms within the production system. Similar to the previous results, we have the predicted outbreak risk along our y-axis, and farms are color-coded by their outcome category. They have also been further grouped by the specific number of outbreaks they have experienced in the last 5 years, giving further insight into which farms may be at the most risk. The other main result presented by the app is the individual local contribution of biosecurity practices. This is the impact of specific biosecurity practices at individual farms, giving a tailored insight into how a farm's outbreak risk is being influenced by its biosecurity strategies. Firstly, we'll start with the color coding. Farms presented in grey indicate that they have not reported an outbreak in the last 5 years, whereas farms presented in red indicate they have reported at least one outbreak in the last 5 years. We then move to the size and direction of the bars. Direction of the bars indicates the type of effect this biosecurity practice is having on the outbreak risk. Those heading in a negative direction are contributing to a lower outbreak risk, while those heading in a positive direction are contributing to an increased or higher outbreak risk. The size of the bars indicates the size of the contribution they are having. Larger bars are having a larger impact and therefore will have more influence on the predicted outbreak risk result than biosecurity practices with smaller bars. In this figure, you can see that while the farm has a negative outcome, sharing a semen delivery vehicle with 6 other farms is contributing a lot to increasing their predicted outbreak risk. However, while some of the results may seem straightforward, we do have to be cautious in interpreting these results, as there are complex mechanisms behind them. For example, in this figure, knowing the disease status of the surrounding premises appears to increase predicted risk. That does not mean that not knowing the disease status is going to reduce the risk. Instead, it may be that you are more likely to know your neighbor's disease status if that farm is infected, which itself will increase the risk of infection on your farm. Any decisions to change biosecurity strategies based on these results should not be made without in-depth discussion with veterinarians or researchers. If you would like to find out more about the research and services we offer, please visit the Machado Lab at this URL. Thank you.